All right, so this is a magnesium and hydrochloric acid stoichiometry lab. So you're going to use what you've learned in class and apply it to a lab. Usually we would do this, you would actually do the lab, but obviously that's not happening. So for part 1, number 1, you have to write a balanced chemical equation. So put what magnesium is. I am telling you its hydrochloric acid is HCl. It forms magnesium chloride, and then you can fill in the well, I better tell you the hydrogen gas. Hydrogen gas is H2 because it's a diatomic. So you put in what magnesium is, and then you write a balanced chemical equation for part 1, number 1. The next thing we're going to do, we already, the other ones are just looking up the masses or comparing coefficients. So once you get your equation balanced, so for number 2, for 1 mole of magnesium, it makes 1 mole of hydrochloric acid. Well, if the coefficient in front of magnesium is 1 and the coefficient in front of hydrochloric acid is 1, that would be true. And that's what you have to figure out. If the coefficient in front of magnesium is 1 and the coefficient in front of hydrochloric acid is 2, then this guy would be true. So that's what you do for 2 and 3. You're looking at the coefficients. 4, 5, and 6, and 7, you're adding up the masses from the periodic table. So that will not be difficult for you. For part 2, making a prediction. So these are your videos that you have to watch. You're going to be trial 1 because you're period 1. So if you're period 2, you're trial 2. If you're period 7, you're trial 7. And if you're period 8, you're trial 8. And is there only 6 trials? Because there's usually 8 trials. There's only 6. Okay, so I'm going to change that up a little bit. Yours doesn't change. Period 1, trial 1. Period 2, trial 2. Period 7, trial 3. And period 8, trial 4. There we go. All right. So I guess you're period 2, you're trial 2. I'm losing my mind today. That not working just threw me over the edge. So you're period 2, trial 2. All right. You can watch this video as many times as you want. This, the balance, that will be giving you the grams of magnesium that they're using. They will then put that magnesium, into the hydrochloric acid. So they will weigh out their magnesium. I just want to make sure you know what's going on. They'll weigh out their magnesium. You'll get that mass. They'll put this magnesium into this test tube. In this test tube, it's hydrochloric acid. A reaction will start taking place. You'll start seeing bubbles. The bubbles that form are a gas. That gas will then exit and go down here and start filling this test tube. If you look at the balanced chemical equation, that gas is going to be hydrogen gas. And then you'll see this piston start moving down, and you can see how much gas you are collecting. Okay, I believe each of these graduations are 5 milliliters, and that will help you. It's a lot easier than the last one. For number 4, you will have the grams from the balanced. You will have the grams of magnesium that you got from the balance. You are showing how you change that to moles. And you already know how to do that by dividing by the molar mass. So show me the work right here. Some of you like to submit pictures. That's fine. If you want, you can do all your work for all of these on a separate piece of paper and submit a file. That works also. So for this first one, you're taking your grams and you're showing me how you changed it to moles. Number 5, look at your reaction. Look at your balanced chemical equation. So you're saying if you use so many moles of magnesium, how much hydrogen gas should be produced? So this guy right here, it's just a moles of magnesium to moles of hydrogen gas. And this is just, this right here is from your number 4 above. Okay? So it's just a mole to mole problem. Really easy. Really, really easy. Don't make this difficult. So then again, like you always have to do, you have to lock an answer. And then you go to part 3. All right, part 3 is just a continuation of the reaction that's going to show, and then it's going to stop. When it stops, then you can continue answering these questions. Number 1, you just watch the video, and number 1, that's how you answer that. Number 2, you can figure that out. Number 3, you have to go up and look to see where this plunger goes. This is your volume in milliliters. They tell you each of these are 5 milliliters, so you just have to add up. Well, do I have 5 milliliters, 10 milliliters? I don't know. If it's if this plunger is pushed all the way down, then you would have 100 milliliters. It all depends where this plunger goes. Every trial is going to be different. So that's how you get number 3. You have to look at where the plunger goes to record your volume. Make sure you use units for number 3. So you'll have like something milliliters. Number 4, it tells you exactly how to do this. So number 4, they want you to figure out how many milliliters or how many moles were produced in your trial. So you're going to have a volume. This is so hard. I'm struggling here. I don't have my right setup, but at least it's working, so that's all I care about. So you will take your milliliters in number 3, and you will divide it by 22,400 milliliters. And that will give you moles of hydrogen gas. So whatever you got in number 3, that previous, the problem right before it, just divide it by 22,400. Number 5, you're finding your percent error, which you have done twice so far. So it's actual minus theoretical divided by theoretical. So your actual is going to be your number 4 in part 3. This is your actual moles of hydrogen gas. You're going to subtract from what you should have got, your theoretical moles of hydrogen gas, and that is number 5 from part 2. And then you're dividing by number 5 in part 2. Times 100. This right here, it's absolute value. So if you get a negative number, make it positive. And then it says what might lead the actual result to be different than your prediction. That's going to be your individual opinions there. All right, so that's how we do the lab.